Hey everybody, my name is Alex Schoaf. I'm from Fugue, and I don't know if you're like me or like anybody that I've ever worked with, but configuration management tends to be a little bit of a dirty word. Usually, most environments that I've worked in, configuration management conjures up these really horrible, repressed memories of red tape and bureaucracy and change control committees. And you know, provisioning used to be that way too. Years ago, anytime you wanted to get some incremental amount of capacity, you had to go through a long process, talk to a lot of people, get a lot of approvals, and then something really funny happened. Vendors like Amazon came out with really good automation and great services, and provisioning became really cheap, and it became easy, and it started becoming a real driver of value and of innovation. All of a sudden, provisioning wasn't a barrier, it was a tool that we could use to move faster and to drive more value for our customers or drive the mission further. And we're seeing a really similar thing happening right now with configuration management. Better tooling, automation, and good services, things like OpsWorks and CodeDeploy and pipelines, which Alex and Brandon are going to be talking about in just a minute, are helping us move CM from being a barrier to being a tool. We can have our developers work with environments that look much closer to production so they can move faster and have fewer bugs. And we can sleep better at night knowing that the environment that we deployed yesterday is the environment that we still have running today. At Fugue, we're taking this idea to the next level and we're making it easy for you to provision, validate, and enforce infrastructure that's running in the cloud. We make it really, really easy for you to move fast, see everything, and get it right. So if you're trying to figure out how to have programmatic, highly automated infrastructure in AWS that looks the way that you think it should and that maintains your internal compliance or governance guidelines or rules, then stop by the expo hall and see us. But let's go ahead and give it up for Alex and Brandon.
Welcome, everyone. How's it going today? My name is Alex Corley. I'm Senior Solutions Architect with Amazon Web Services. I've been with the company for 3 years now, but I joke that I come from a long line of startups, right? So I've been a customer since 2008, kind of bringing DevOps to the public sector here. A lot of rigor with DevSecOps and continuous integration, continuous deployment, configuration management. Thank you.
Hi, my name is Brandon Bouillet. I am a digital service expert or engineer with Defense Digital Service. I've been there for a little over 14 months now. I'm a little bit of an odd duck in that most of my counterparts at Defense Digital Service or United States Digital Service, which works out of the White House, came from the private sector, the big tech companies in Silicon Valley and everything. I myself have 15 years in government, at the federal, state, and local levels. So we're here to talk about how we use things like DevOps and GovCloud and some of the work that we were doing at Defense Digital Service.
So just wanted to spend a little bit of time talking about the migration story, if you will, cloud adoption. So kind of how is cloud different from traditional on-premises physical infrastructure? So you may be used to kind of long-lived physical servers, right? Things that you configure by hand, potentially have some automation, configuration management, maybe some shell scripts, if you will, to start building these machines. A lot of this runs on static IPs, static DNS, right? Kind of statically typed resources. Heavyweight configuration management, right? Again, kind of, if you follow the ITIL process, maybe you have run books, a lot of kind of processes that you follow by hand. And then there's a lot of kind of distributed challenges in the physical infrastructure, certificate management, key management, kind of how do we ship secrets securely throughout our infrastructure? And so those are some of the things that we're going to talk about kind of as we transition from on-premises into the cloud. So configuration management libraries traditionally can get rather complex, right? If you're familiar with Chef, Puppet, Ansible, those types of things, you kind of start off with a pretty simple kind of action, if you will, right? A recipe where you maybe configure a application or a service, get it running, get the configuration files there. So a lot of kind of management, if you will, for all of your configuration. A lot of times this requires specialist developers, right? Because these are special tools. You have to have someone that understands the ecosystem of distributed systems, kind of how all these things interplay. And then also, just as you do with your application code, you have to start writing unit tests, functional tests, right? Test harnesses, so that you can verify the state of your infrastructure after it gets deployed. And then, I don't know if any of you have gone through this, but as I stated before, you usually start off with one simple file and then end up with kind of thousands of lines of code, maybe a rather robust set of configuration management files. And then that kind of takes on a management burden in and of its own, right? So those are some of the things that we're going to talk about, kind of the journey, if you will, as we move from on-premises to cloud infrastructure.
So one example that we have at Defense Digital Services, we work out of the Pentagon, so we were working with a government contractor trying to do work on next generation GPS, like the GPS that everyone knows and loves. And when we arrived at the contractor, they were having difficulty scaling their development infrastructure. They were literally trying to rack and stack servers and were running out of space, and the costs were growing. And their ability to have a consistent repeatable deploy of their environment was difficult because everything was being manually done. So the problem was that each of these environments, because they were manually done, were slightly different. So there was a very strong incentive by the developers there to preserve these environments because they coded against that one particular environment, and because the other environments may be slightly different, they were very reluctant to have any changes. So the idea of trying to tear it down and rebuild it was, met with a lot of resistance. This obviously dramatically increased the effort involved with trying to actually do your development work and make sure that it was consistent. Remember, these are development environments. They don't necessarily match the production environment this is going into. So the odds of them having issues when they try to deploy this to production were dramatically higher, and there were difficulties in trying to even migrate this from one development environment to another. And because it increased massively the amount of time it took to get this stuff to work, as software and hardware was lifecycled out, they would run into additional problems with trying to replace that and have more issues and breaking. And so there was absolutely no guarantee that there was any continuity. Even something as simple as creating your test harnesses and your test environments to validate that your environment was good would break as soon as you tried to do it in another environment. And so they'd be back to square one. So that was the kind of scenario that we walked into. So we had some initial questions, and these are actual questions that we asked, and we asked the contractor to look into, was how many different environmental tweaks are defined in your deployment scripts, and how could the program eliminate these? They had automated deployment scripts that they were working on. They had a lot in place and more that they were still building, which is actually quite far ahead of the game compared to many other government contractors, trust me. However, they had a lot of conditional statements and a lot of checks to see, hey, okay, if I'm running in this environment, I need to check for this stuff, but I run in this environment, I need to check for this other stuff, and if I run in, this is all just dev. Now, if I go to test, I gotta check this test environment, see if this is going, and so their scripts ballooned in size and complexity, and they had teams who did nothing but try to manage the scripts to manage the infrastructure for the code that the developers were then developing on. It ballooned exponentially. Other questions. How many DRs, defect reports, are a root cause to environmental or platform issues? Because of the complexity of the environment that they were working in, there was rarely time, and also because of schedule pressures, there was rarely time to really dig into what the root cause issues were. Anyone who's familiar with traditional DevOps may think of like the 5 whys, where you ask why basically 5 or 6 times until you try to get to the root cause issue. There was never that. There may be one why. Why did this break? Because the script didn't run. Well, fix the script instead of addressing the root cause issue. And the other question is, can existing automation be used to deploy into a real operational environment? These difficulties that they were dealing with were primarily limited to their development environment, Not because their test and production environments were perfect, no. It's because they were stuck in their development environment. They hadn't had an opportunity to significantly migrate to their test and production environments because they couldn't get out of the development environment. The multiple different environments, and we're talking half a dozen or more, just the development, were stifling their ability to strongly progress into test and production.
So this is where AWS kind of comes in. We talk about the undifferentiated heavy lifting, right, that we take on as the burden from the customer. And so really what this means is, we're an IT delivery shop, right? We follow the NIST definition of cloud computing, the on-demand delivery of IT resources over the internet in a pay-as-you-go model. So just-in-time delivery, right? So that you as the customer can start focusing on the business logic, what makes sense and what is unique to your specific organization, and allow us to kind of manage a lot of this overhead and take the burden off of you. So really where this comes in is, again, automation, starting to take a lot of the kind of necessary but repetitive work and put that into infrastructure as code so that you can version control it, put it into your build continuous integration deployment pipeline, and get a kind of workflow or assembly line for your artifacts, both to development, staging, and production. And so originally, these were kind of the physical infrastructure, right? Infrastructure as a service. So in 2006, we came out with EC2, and then we added S3. And here we are a decade later where we have kind of infrastructure as a service, platform as a service, software as a service. And we're really starting to kind of build on all of these core blocks to create an enterprise-level ecosystem. And so now, instead of just replacing the physical infrastructure, the electricity, the cooling, the redundant internet connections, now we're actually talking about managing the complex configuration of your infrastructure and your application. And so this also includes monitoring and logging, right? This is not just the deployment of your infrastructure, but it's the continuous care and feeding and watching of that infrastructure as well. So how is cloud different than on-premises infrastructure? We have a feature called auto-scaling with EC2 that allows you to dynamically grow and contract your infrastructure based on a metric. Most of my customers do this on some sort of business logic, right? So you can start with CPU utilization. Is this machine overburdened? If so, add another. If those two machines are receiving less load, you can remove that back down to one, right? So dynamically growing and contracting. Some of the problems this adds is hosts are significantly shorter lived than traditional physical hosts, right? The traffic patterns of your customers, depending on how you set this up, some of my customers do API latency or page load time, number of concurrent users, right? Whatever makes sense to your application. And so as you add machines and remove machines, instead of this happening on week or monthly kind of capacity planning cycles, this can actually occur within minutes or within hours of growing and contracting. And so that's why we're kind of talking about a lot of these concepts and topics, is so that you can address some of these ephemeral kind of elastic hurdles as you move to the cloud. Also patching, right? So golden images of creating a machine image so that when the machine boots, all you're doing is maybe installing the latest dependencies or the latest version of your application so that you can start kind of building these into artifacts at a base level and then adding your application and configuration management on top of that. So we have a number of services that will support these actions. Going to talk in detail about quite a few of these services, and then Brandon will kind of mention, how they've leveraged some of these to solve some of their business problems. And so CloudFormation is a template service. It supports JSON and YAML. It allows you to literally define your infrastructure and also the relationship of those infrastructure components with each other. So you can say, not only do I want a network topology, a load balancer, web servers, and database, but you can also specify security groups, orders of operation, and add some logic in there to start building kind of service orchestration, if you will. We have CodeDeploy, which kind of allows you to begin to separate your infrastructure and your application deployment processes so that you can define your infrastructure in a CloudFormation template and then use CodeDeploy to deploy or roll back your application. OpsWorks is essentially managed hosted Chef. So if you are using Chef in-house today, we have an entire service platform that can help you kind of not have to manage your Chef infrastructure. And then Elastic Beanstalk is an application hosting service. So if you don't want to deal with kind of system administration, infrastructure administration level actions, you can literally feed it a zip file or point it at a Git repository and have it take your code and deploy it into a fully configured application stack, right? Elastic Load Balancer, web server, your application code, maybe a supporting managed database. And so entire ecosystem for deploying your applications and code. I've talked a little bit about building blocks here. I come from a POSIX background, and so I see all of the AWS services as kind of cut, grep, cat, awk, sed, right? You're building a pipeline of information flow and maybe altering or inspecting that data at different stages. And so when you think about AWS services, I see them as Lego blocks where you can kind of build the house or the infrastructure that you're looking for out of a number of these core building blocks. So to spend a little bit of time talking about CloudFormation, I already mentioned JSON and YAML. So this is version-controlled artifacts that you can do ITIL type configuration management, change management control, and build this into your workflow. Really where this comes in is kind of taking a look at the traditional physical infrastructure, right? The concrete of your data center, and start building this into the CloudFormation templates. So as I mentioned before, your network topology, so a virtual private clouds. A lot of people see the cloud as like this anomalous public infrastructure. I just want to point out with a virtual private cloud, you do not have to put an internet gateway on this. So it can actually be a completely isolated, logically isolated network, completely separate from the internet. You may join that with your on-premises infrastructure via an IPsec VPN tunnel or a fiber connection or something, but it really allows you to extend your on-premises infrastructure using a version-controlled file. So subnets and security groups. Our security groups are stateful, deny all by default firewalls. Right? So kind of a number of compliance regimes require some of these concepts. We have them built in by default. I've mentioned auto-scaling groups, so you can define the minimum, the maximum, and some of the scaling metrics that your infrastructure responds to all in this single template. And then load balancers as well, right? So you can build in certificate management, SSL offloading, application load balancer at layer 7. So a lot of kind of features and functionalities that you can leverage here. You can put all of these resources into a single template. So as Brandon mentioned, kind of reducing deltas between environments, right? So this is one file that may have a small amount of logic, right, for environment. Is this development? Is this test? Is this production? But not a large amount of logic within a single environment, right? So again, we're trying to reduce the number of changes that occur between development, staging and testing, and production, so that you have confidence that the artifact you're building and deploying will operate in the same environment no matter where you do that. This is just a little example of some of the JSON code. And again, this is not just dev, staging, production. This could also be multiple geographic regions. So AWS has a global infrastructure. Most of the concepts and things that we're talking about here today are mostly based on CONUS, continental United States, and our GovCloud region. So most of my state, local government, and federal customers tend to choose GovCloud as a region. And so all of the things that we're talking about here are available in GovCloud. So just a little bit of deep dive onto the CloudFormation. So how does this work? There's an agent that runs on your virtual machines that accepts kind of communication from our work plane. And so when the machine boots, we run cfn init CloudFormation initialize, and that allows you to do a number of actions inside of the operating system. So this could be installing services, configuring dependencies, a lot of different options here. A lot of my customers in this section ship their secrets, if they do have secrets, right? So you can encrypt in transit, encrypt in rest, and least privileged kind of move these artifacts within the ecosystem. And then also CFN Hub. So this is for when your infrastructure is already running, but you want to induce changes. And so this will kind of accept configuration deltas inside of the system so that you don't have to reboot a machine or deploy a new machine. You can actually make changes in line while things are still running. Realize this is a little bit of a kind of eye chart, if you will, but I want to point out the blue code there. So this is JSON, and this is a specific chef reference, but I really just want to point out that it can be as simple as running one command, right? And so this one is a specific application, but we could parameterize the inputs. So you could use this one template for a multitude of applications. So it could be application 1, application 2, right? So again, removing deltas at an infrastructure and almost an application level, depending on how you configure these.
So at the defense contractor, one of the things we were trying to emphasize is to get them to focus on automating their build and test environments. We didn't want them to be stuck in the same framework and state of mind of manually testing and manually trying to configure all of their stuff. So they only had a couple of teams. I mean, they had hundreds of developers working on this project, but they only had a couple of teams that were actually using like continuous build infrastructure, things like Jenkins and stuff like that to actually, as a part of their day-to-day development. It just hadn't really caught on. A lot of this was due to the fact that there was no confidence in the existing state of the development systems and developing environment, and no one really had time to try to build this out. And the training on unit and functional test tool sets was offered to different engineering teams. Some took it, some did not. We re-emphasized the need to focus more on that, which was met with a little bit of resistance at first, like oftentimes unit and functional tests are, because at first it appears like this is just extra work and we don't have time for this extra work. But it ended up paying dividends definitely down the road, especially as you start automating your infrastructure. And the fact is, because this wasn't emphasized prior, writing good tests was a new skill for most of the engineers on the program, because most of them have just been driven by code coverage. I kid you not, I'm not exaggerating here, I'm sure some of you guys would know this. Some of the actual metrics, one of the metrics, the actual metrics by which the success and progress of the project was measured was by KLOCs, thousands of lines of code written. That was disproven as an accurate measurement for software development back in the 80s, and yet it is still used as an actual metric of how, well, you have this new 10,000 lines of code, so I guess you guys are doing pretty well, as opposed to actually seeing whether or not it was functional and actually working. So introducing new ways of doing your automated tests went a long way, although it was met with some resistance. So some of the questions we asked them and told them to ask themselves was, how long does it actually take an engineer to make a code change? We have heard some stories, not just at this contractor, but within the federal government itself, that some of the engineers there who are doing the development, maybe a 2-hour code change, doesn't take them very long to do. And then it takes months before that change is reflected in the system in production. By then, the engineers might be working on a completely different project. Maybe it doesn't work. Then they kick it back. Well, the engineer needs to try to figure out, when did I make this change? What was this about again? And have to go back and do that. We have to try to shorten that. But first, we have to raise the question. It was something that they didn't even think to ask. How fast is each continuous integration build and test cycle? How quickly do you get the feedback? How quickly are the tests run? Do you get that feedback within minutes? Or does it take days or weeks before you get the results of the test of your development work? You have an entire separate team that requires a massively long manually process of checklists of what you have to do before the tests are even run, and then you get those results back, and by then, several weeks have passed. How many defects are found by the unit test or the functional test? Are your tests working? Do you actually get defects? Are the developers notified immediately, maybe automatically, of the defects in their code that they've written? Maybe as soon as they checked in the code, so they are already, while it's still fresh in their mind, they're able to fix the problem and solve it. Or does it take days, hours, days, weeks, maybe even months before they get those results back? Which code style and security checks are validated automatically as part of the build process? Now, in government, public sector, at all levels, there are a lot of checks and things that have to be taken into account with code style and especially with security. At the federal level, we got STIGs for days that have to be taken into account. How many of those can be automated? How many of those that can be automated are actually automated? So you have this automatic STIG validation. So you don't have to have an entire team of people who are just sitting there telling you no, 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 no. And how does the test organization participate in the automated test efforts? Just because you can do things like automated unit tests and functional tests, maybe even automate some of the integration tests here and there, doesn't mean you don't need a testing team. You might be able to automate things like an end-to-end test to represent some user involvement, but that does not necessarily completely replace the need to have an actual user look at the system and work with it. That does not replace the need to have thorough integration testing when you have a large, complex organization. So oftentimes what we've seen is that when we start talking about things like automated unit and functional tests, the people who are part of the testing team start getting really resistant because they think it's a threat to their existence. And we say, no, 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 no. This actually cuts some of this redundant work off your plate so you can focus on the quality of the tests that you guys need to do.
So AWS CodeDeploy, cross-platform, works with Linux and Windows, allows you to build a number of these test harnesses, gates, if you will, right, for quality checking as you build your development environments. There are a number of kind of hooks, if you will, for the application lifecycle. So application stop before it installs, after it installs, after the service starts, and then there's a post-validation step. And so really where these come into play is you're able to both deploy and roll back your application. And so again, kind of taking this undifferentiated heavy lifting, if you will, for the application deployment process so that your developers can focus on code quality, test quality, right? And not worry about the assembly line of how that quality actually gets out the door. So rolling deployments allows you to specify a few kind of simple metrics. So you can do 1% of your fleet, 10% of your fleet, 50% of your fleet, and then verify sanity and validation checks or rollback, right? So again, kind of gives you the ability to make incremental deployments, perform experiments, fail fast, roll back fast, so that you get these tight feedback loops, right? So instead of waiting weeks or months for your change to go out the door, maybe there is a defect, you have to context change and switch back to where your thought patterns were maybe weeks or a month ago. This again really gives you that assembly line to get the artifacts out the door. And then again, decoupling your infrastructure from your application so that you can leverage CloudFormation for the concrete or the physical infrastructure, right, as you kind of see that with your on-premises deployments. And then you can combine that with CodeDeploy so that maybe your infrastructure teams can manage the CloudFormation templates, and then your development teams can actually manage the CodeDeploy process. So least privileged separation of duties as you're working through the development process.
So speaking of deployment automation, at the contractor, there was no real clean automated procedures for deploying the software into the environment. Now, they were working on it, but because of the restrictions that they were facing with actual trying to physically rack and stack some of this hardware and physically network all this stuff and procure the hardware, which took weeks and months by itself, they didn't really have a lot of processes involved for automatically deploying software onto that hardware because it was different. And so there were few clean and working manual procedures because just the procurement process alone could take months. And by this point, the hardware or even some of the software that they would get is a different version of what they already had in place that they procured months earlier. And these are environments that are dozens of servers large, like 100 typically in a typical environment. And so we had a recommendation that all of the deployment automation be treated as a software engineering product, the automated infrastructure. Test first in the cloud. Use the cloud as an extended environment. So you don't have to, at the very least, at the bare minimum, you don't have to worry about trying to figure out where you're going to dedicate your server room, where you're going to run the power and AC, where you're going to rack and stack all of this stuff. Because this was OCX, these had to meet certain stringent government requirements, these data centers, and that in and of itself took another process, whereas GovCloud already met those requirements and could scale as needed. It was kind of a no-brainer. So that allowed them to focus on instead cleaning up and expanding their use of the automated deploy. In this case, they were using chef scripts to get those fixed up, make them idempotent, and get it to the point where they can automatically and repeatedly and reliably deploy their infrastructure and the base software on top of that so that the developers now have a consistent environment from which to work in. So some of the questions we asked there was, what is the delta between each development test environment and the eventual production environment? The deltas that we walked into were huge. There were massive deltas between the different development environments, let alone the test and production environment. And one of the things we stressed, and re-stressed is the closer you have your dev, test, and prod environments in terms of their infrastructure, the smaller these deltas are between them, the more confident and reliable you are when you go to deploy and migrate your software through dev, test, and prod. It's kind of common sense when you think about it, but it's still something that really needs to be driven home in government. How often is the system torn down and rebuilt using the automation? Like I explained earlier, because these were manually built systems of hundreds of servers and physical data centers that they were maintaining, the desire and just the flat desire to tear these down and rebuild them was non-existent. Hey, we need to add more hardware here. Hey, this needs to change. It's like, you're not changing this. You know how long it took me to set this thing up? No, we're not changing that at all. That was a problem when you're talking about multi-year long projects that can take a very long time to complete. They're now, the hardware that they're using, the software, the operating systems, that stuff's now out of date. It's no longer supported, but there's a reluctance to change it. And so that was causing the development environment to become stagnant and out of date. How much automation software is reused with minimal modification between environments? If someone did take the time to get a good infrastructure deployment in this one environment, how much of that work and effort could they then just quickly and easily reuse in another environment? The answer was not much when we found. This was a question that they did not raise. They felt it, but it didn't occur to them to really try to quantify, measure, and fix it. Is that they were reinventing the wheel every time they went to a new environment, which was wasting a lot of time, effort, and money. And how much time is required for the manual application of workarounds to produce a working system? They weren't quantifying how much effort it was taking just to try to figure out how to move this to other systems. Once they started quantifying that, once we started getting some base metrics on that, at the top, the bean counters' heads exploded. They were like, oh my God, we didn't realize how much effort it was costing us just to figure out how to work around an environment. When they factored in that cost, the perceived worry and cost about going to the cloud became a much more amenable to them.
So just to spend a little bit of time talking about Beanstalk. So again, application hosting service. So it's fast and simple to begin. You literally can feed it a zip file. Most of my customers, to get started with this, I go to the wordpress.org website, download WordPress, feed it the zip file, and we have the beginning of a continuous integration deployment pipeline. You may replace that with a specialty in-house application or another open source application, but it can be that simple. Increases in developer productivity so that they don't have to worry about kind of handing things over the fence, right, to the build and deployment team, the infrastructure team. They can kind of self-provision inside of their own development environment with the restrictions you place on them with identity and access management controls. And then complete resource control. It handles the configuration of the load balancer, the EC2 machines, your managed database. It takes all of that off your plate. So just to kind of speak to some of the components here, right? The capacity planning, load balancing, auto scaling, health monitoring, all of that is built into the system. So anything that we can see from the cloud service provider's perspective, CPU utilization, disk I/O, network throughput, we auto-populate all of these metrics for you so that you don't have to go in and add monitoring and logging. We can do centralized logging so that you get an indexable log kind of repository for development, production, test. You can feed it your load balancer logs, your application logs, and your operating system logs so that you can trace maybe an IP address as it flows throughout your infrastructure. And then a number of interpretive languages are supported here. So no matter what you're using in-house, we also support Docker containers, so you can feed it a binary artifact for immutable infrastructure, right? A little bit about OpsWorks. So service orchestration, not just an individual machine, but we're actually talking about your entire infrastructure at this point, all of your different components of your application. You can customize each one of these components specifically to that layer in your application stack. And then you can also, in near real time, respond to events to incur changes. And so just a visual example here, you can kind of see, we have 3 different layers here, app, database, or 2 different layers, app and database. And so there are lifecycle events where you can start the app server, deploy the application. Only once the application is deployed do you then populate the database. You can then reconfigure the application now that the data store is there and available, right? Maybe pull some configuration into the application. You can start and stop services, change user permissions, and all of these you can coordinate between layers of your application stack so that you can set dependencies, orders of operation, and really get the flow of deployment to match your business logic.
So one of the big components that we worked with the contractor was infrastructure automation. So the existing infrastructure automation team was primarily focused on their documentation because it's government. The policy trumps all in a lot of cases, even in software development and infrastructure. And so they didn't really have a strong skill set in system automation. What they were doing is they're physically racking and stacking all this infrastructure, and they document what they did, and then the document was supposed to be the way that you would go and rack and stack this in another environment. Or they would pass that over to the actual government, who would then have to go and rack and stack this in the production system and hope that everything was captured perfectly and they didn't miss anything. So we just recommended start small. See if you can automatically and repeatedly just go ahead and build out some of your basic infrastructure on the cloud. And instead of writing all these reams and reams of paper documentation, let your automated deployment scripts and your infrastructure automation scripts be the documentation. If it executes and produces the environment you want, great, you got it. So they, like I said earlier, they were writing a lot of chef scripts to do a good chunk of the provisioning of the infrastructure once they had it deployed, and they were focusing primarily on hardening them to meet all the STIG compliance that they had to focus on. So they were literally trying to pull in a lot of chef experts to get this stuff done, because they were trying to take into account all of the small nuances between the operating systems and the other hardware that they were working with on all of this physical infrastructure. Whereas once we started pushing them to the cloud and they had a more consistent look and view, they can have more reliable understanding of this is the version of operating systems we're using. These are the different operating systems we're using. This is what our hardware makeup is. They simplified these chef scripts dramatically. They didn't have to take out looking for all these edge cases, and they were able to focus more on making sure they were compliant with the STIGs and hardened appropriately. So some of the questions we brought up there was, how long does it take to harden a new deployment? Turns out it took quite a while because each of these environments was different. That simplified greatly. Once they figured out one environment in the cloud, it was automatically transferred to all the other environments in the cloud. How long does it take to prove that an environment is compliant? How did they verify that they were doing it right? It turns out that, and this is true in most of government, unfortunately, that there seems to be this assumption that compliance equals security. And so if I can check all these boxes in a list, it's secure. So no, that's not true. Now we have a means when we have these automated systems to actually easily test and see, can I actually access this port? Am I pinging a server? Is all of this stuff actually working the way it's supposed to work, as opposed to just checking a box? How are administrators notified if an environment is out of compliance? So how do they actually know if it isn't working? Before, it was a checklist. You check the box and everyone was like, oh, it must be good. But if the system was actually out of compliance, how would anyone know? And so now you can have a situation where you can have the environment actually let you know when something's out of compliance. How long does it take to get a non-compliant environment back into compliance? So assuming you actually did find out that your environment was out of compliance according to whatever your policy is, how long does it take to get it in compliance? How does that affect your overall schedule? Does it take weeks or months, or does it take minutes? Well, previously with manual effort, it took weeks or months, which is why there was such a reluctance to migrate and change the environments to begin with, because they knew all of the built-in edge case logic was already in that environment, not really documented anywhere, and so they were very reluctant to change. What tests are done to verify that the environment hardening is effective? This goes back to the earlier question about how do you actually verify that this, quote, checklist of things you have to do are actually in place? Or did someone just go through and check the box because that's just what they do? Well, you can write tests to actually verify that and make sure that this is actually secure in a way that works for you.
So all of this is infrastructure as code, right? So we can put this in a version-controlled file, do change management, change control, whatever your administrative policies or compliance requirements are, you can apply to this. And then also do near real-time remediation. So as we go through some of these, we're going to talk about config rules. So config rules is a service that is built on top of Lambda that allows you to respond to changes in your cloud infrastructure. So if a security group gets changed, you can trigger an event, check to see if that security group change is in line with your policies, right? Maybe they went from 443 to 80 and you only allow SSL, so you can have a remediative action to change that security group back to only 443. So a lot of kind of power here with enforcing your guidelines. And then we see these again, kind of as I mentioned before, coming from a POSIX ecosystem as a toolbox. And so all of these services can be combined together to build the home or the house that you're trying to do. Not a single service is a hammer. Not everything is a nail, right? So we can use these different services to solve specific engineering problems. Organizing by layer, so not just test, production, staging, but also environment. So we could go from East Coast to West Coast, or to Ohio, our Middle Coast region. And then we could do service-oriented architecture with all of these, so we can begin to decouple all of our components so that we can scale them individually for individual throughput requirements of each individual component. We can do nested stacks so that you can give your security team permission to manage the firewall rules separate from the development team, and then we can merge all of these templates at deployment time so that you get the finalized result in production, but still get the compliance and security workflow for risk mitigation.
So for platform automation, you had the physical environments that were being configured manually, just like everything else, and of course they inconsistently suffer from periods of downtime because of all the manual configuration. Someone might miss something here, or something was overdone there, or because of procurement, things were taking longer than they expected, so they have all this downtime, unplanned of course. And so we recommended that you use AWS GovCloud to replace your physical hardware for all of the use cases, except for those specialized situations that require classified, fully classified data that was super secret or required super specialized hardware. There's actually a small fraction of most federal government and state and local as well actually has that kind of requirement. Now, if you talk to people in the government, they think everything has that requirement. That's not true. A very small fraction actually does. We also saw that AWS, when we actually put it in place, reduced their time to build and test a new system and environment from 3 weeks on average, and sometimes as long as 3 months, to 3 hours. And there was nothing that we did or said to them that drove the point home more than when we were actually able to just click a button and saw their entire environment built out, tested and verified consistently, tear it down and do it again in less time it would take them to get a server and rack it. That is when it was like, oh wow, this stuff might actually kind of work. You know, I didn't think about this before. It's like it went from not no to how do we make this happen? How do we grow this? How do we make it go even further? We actually had to tell them to slow down a little bit and start small and grow. But that is what really drove the point home, when they actually see it in action. So some of the questions we brought up here. How long does it take to implement a platform change in the environment? If you need a new piece of hardware, if you had a change of your architecture and design, how long does it take for that to be implemented? Turns out, in the cloud, much faster than it would take to do it yourself. How far behind the platform baseline does each environment lag? They have a design. They had designs of how this environment should look. It turned out that none of their actual physical manual implementations actually matched the design. Because, you know, as they physically build it, they will uncover things, but there was no good feedback loop between them and the actual system architects. And so nothing was ever actually in place. So not only was their documentation, the designs and everything incorrect, it was actually actively misleading because there was an expectation set that wasn't reflected in reality. How many system instances were running in the cloud? They can verify that easily in the cloud. They couldn't verify that as easily manually and physically because they didn't have the monitoring in place to do so. How many development teams are using the cloud systems as their primary test platform? This helps them see how well the adoption was taking place. And it turns out the adoption was growing quickly. More people were using the system than they had initially planned because word of mouth spread faster than their actual staged rollout. And which physical systems are still in use and why? This helped them identify why were they still using physical environment X versus going to the cloud, which was much more reliable, upright, distributed, secure, and everything. And they were able to now ask that question and find out exactly why and see if they can incorporate some of those reasons into the cloud environment and make that work.
And so just as a wrap up, just wanted to kind of bring home the just-in-time delivery concept. So traditional infrastructure includes capacity planning, procurement, installation. With AWS, you literally can do these things in minutes. So multiple environments, multiple geographic regions, multiple application types, right? So servers, data warehouses, all of these things can be just in time delivered. And then next steps, so I just wanted to point out that GovCloud very recently got Lambda. Just last week it got config rules. So a lot of exciting new possibilities for our government customers in a highly regulated environment so that you can begin to codify your compliance and security requirements in near real-time remediation. Thank you.
Thank you.